I had some poll in YouTube, and so this is one place, it says majority need not be right. Okay, so most about 60% voted for 300 pi by 360. Official key is C. A strong contender here is 10 pi by 360. So quickly, what would be the answer here? They have deliberately set traps. This is a trap. This is an obvious trap. That is, okay, you look at 60-degree phase difference, perhaps, 3 by 300 by 360, something like that you do. This is like a somewhat an obvious trap. It's also a trap. This is a very, very, actually a clever trap. They have intentionally set this trap. So I'm not going to say they meant this, there is any ambiguity here. The answer key makes sense to me. Best way to look at this is as a phasor diagram. Okay, in the complex plane, we have real part, imaginary part. Notice in the real direction, this corresponds to cos omega t. Okay, we measure angle, positive angle this way. Okay, positive time. Okay, any angles positive this way. And this corresponds to imaginary part, specifically, negative imaginary axis. So complex plane is this. This is sine. This direction corresponds to sine omega t. Notice sine and cos has a 90-degree phase shift. Even if you don't remember trigonometric identities, you could say actually take cos, put a minus 90-degree phase, you get a sine. Okay, you could look at this. So what is given as 2 cos this phasor somewhere over here. So one is, I think, 2, another one is 3. Okay, this is corresponds to 2 cos at an angle of 60 degrees. There is one more phasor. I'll have to, or there is a slightly better way. There is one more phasor in this direction. Notice it's at minus sine omega t direction. Okay, magnitude is slightly larger. This actually corresponds to minus sine omega t. So what they are asking us, notice 2 pi corresponds to a time period, omega times t. So if you know this fraction of angle between the two phasors, you essentially know that you can calculate the time taken. Okay, question is, we have 2 fractions, option 1, option 2. Should we use this angle between this phasor and this phasor, or should we use this angle between this phasor and sine omega t direction? So quickly, what do you think should we do? Anyone has preferences over 1 or 2? And let me also say that I think if you use 1, answer is B. If you use 2, answer is C. So notice, if you were to use 1, you are looking at distance between. So at this point, a thing has a negative peak. It is minus 3. So this phasor is minus 3. After after some time omega into this angle corresponding to this angle, cos hits a peak. Okay. So should we look at distance between delay between positive and positive peak, negative or positive and negative peak? That's a question we have to ask. Okay. So even though the first phasor minus 3 sine 60 is over here, the positive peak for that will happen along this vector along this angle. So the positive peak is over here. The distance between this positive peak to this positive peak should be this angle too. That is very easy to do. This is 60, this is 90. So that is 150 degrees divided by 360 degrees, and you do into 2 pi by omega. Okay, that is essentially I'm doing t corresponds to 2 pi by omega. This is time period. So now this is the time taken to traverse the entire circle, 360 degrees. What is the time taken to traverse part of it? That is, okay, 150 degrees corresponds to how much time? Okay, that simple ratio is over here, and this happens to be 50 pi by 360. Okay, so this is somewhat tricky, and so the positive peak happens here, and yeah, so whenever this has a positive peak, after this much time, this should have a positive peak. So the delay should be 50 pi 360. If you are looking at distance between negative and a positive peak, because peaks doesn't specify positive or negative, you could 10 pi by 360 can be an answer. I don't think it's worth arguing here. Okay, even though this peaks is precisely not correct, I don't think they will accept it. And the trap seems to be deliberate. That reinforces my guess that they won't accept a challenge here. So the key here makes sense. I suppose it's C.